Lesson 33, Science 7, and today we're going to simulate offspring number 2 for our mom and dad. Again, I want you to pay careful attention to the process we're using to create the offspring, because understanding this helps us to answer our driving question: how can siblings be so alike and others so different? So grab the same materials from yesterday and let's get right to it. I need you to start by creating the karyotype for mom and for dad. Use the picture on the screen as a guide. Pause the screencast and do this now. Now remember to turn over all of your chromosomes. This is really important. It's because inheritance is random. Parents can't choose which chromosomes to pass on. It's all chance. Go ahead, pause the screencast and turn over all of mom's and all of dad's chromosomes. All right, you're ready to make a new egg cell. Let's just refresh our memory just a little bit for how to do this. You're now ready to create mom's egg cell. This is her reproductive cell that will pass 23 of her chromosomes on to her offspring. Now this process is random, so what I need you to do is randomly select one chromosome from each pair. Just like this. Randomly select one chromosome from every pairing. Okay, you get the gist. Pause the screencast now, go ahead and create this egg cell. Once you have your egg cell with the 23 chromosomes, paperclip those like you see on the screen. You'll need them for later. Put the ones that you didn't select, the unused ones, in this plastic bag. We're not using them in the simulation. Now, let's use the same process of meiosis to create dad's sperm cell. Again, you're going to randomly select. Here, let's just refresh our memory. We're now ready to do the same process and create dad's sperm cell. Dad's sperm cell is his reproductive cell that only carries half of his genetic material. So again, randomly choose one chromosome from each pair. Make sure that this process is random and that you're getting one in each pair. Okay, so you got the gist, right? Go ahead, pause the screencast, and create dad's sperm cell now. Now that you have all of 23 chromosomes for dad's sperm cell, put a paper clip around it. And then the ones that you didn't select, put in the plastic bag. You're not using them. It's now time to unite the egg and the sperm. Do you remember what we call that process? When the egg and the sperm unite? Yep, that's fertilization. And so now you're going to unite the egg and the sperm and create the karyotype for offspring number 2. Pause the screencast and do this now. Do it just like you see on the screen. Match up the chromosomes for each pair. Remember, this is the one, number 1 from mom, number 1 from dad. This is chromosome number 2 from mom and number 2 from dad. And the child has a chromosome from mom and dad for each pair all the way to pair 23. Go ahead, create your karyotype now. Okay, you have your karyotype all set up, so now you can slowly and carefully record all the gene combinations, the genotypes, on your journal slip. And make sure that you're also recording the phenotypes, what trait the offspring actually has. And I wonder if your offspring is going to be a girl or a boy. Remember, that was pair 23. You can tell in that last chromosome pair. XX is a female, XY, you have a guy. I wonder if this second offspring is going to closely resemble your first one, or maybe not. It's time to see what this child looks like. So use the Visual Profiles reference sheet to help you draw the facial appearances of this second child. Make sure to draw the second child accurately using the data you just collected on your journal slip. Pause the screencast and draw offspring number 2 on your journal slip or just on a separate piece of paper. Now, just like in the previous lesson, I want you to submit your journal slip. This is because I want to see your data and the drawing of offspring number 2. If you did your drawing on a separate piece of paper, then just upload a photo of that drawing to Schoology. Oh, and don't forget to put your chromosomes away neatly again using the paper clips because we're going to need them to simulate one last offspring. Until tomorrow, keep thinking, keep learning, and get ready because we have offspring number 3 to create.